So, hey, thanks everybody welcome to episode 5 of our data science Python study group. Um, this time we've decided to work as hard as we can to get some code examples working and things happening for the actual, for the piece that's there. Joining me as always is Nathan Smith, the actual data science expert for what we're doing. I'm the amateur who plays around with this stuff. And so here we are looking at everything else. I've got all of the code cloned down here in PyCharm, and it does allow you to go ahead and view the notebooks, and it says execute the notebooks in Binder. So maybe that was the issue that I was having, because what I was trying to do was go ahead and view the notebooks, but I could not actually. Sorry, this is some other work I was doing here. That this is the repo, of course, for all of the code with all the stuff in it here on GitHub, and then here's our normal README stuff. Now, like I said again, I was doing the notebook viewer. I was doing the Python examples. Here's our notebooks. We're still, I believe, in chapter 1 and dealing with, at this point, binary data, but none of these examples will actually run. So this is just a viewer here in Jupyter, which, great that they've got a viewer. It just seems kind of counterintuitive to have a Jupyter notebook that you can only see the code in or whatever, rather than actually interact with it. So I'm going to go ahead and I'm going to check this out, execute notebooks in Binder. You got to love the new Markdown in life. So we'll see. This looks like we are spinning it up. I was not aware of Binder until this moment, so maybe this is something. Have you run into this before?
I have not. It looks like an interesting environment.
So this is kind of what I thought we would be doing, like with CodeLab, would be building things in CodeLab, and it would make it easier. But if Binder is something that works, well, hey, great. Then there we are. So it's starting repository. I don't know if this is actually spun up yet. So it says website does not host notebooks, it only renders notebooks. So let's see, Python notebooks, chapter 1. And it still does not appear to actually let you, sorry, here's a non-interactive preview while we start the server for you. So,
okay, so it's still firing up, maybe?
Yeah, it's a lengthy process.
Yeah, we'll see how long it runs. Do you have Jupyter installed locally? We could always run it from your local Python as well.
I do, like, I need to do a little bit more work on let's see, PyCharm. I know PyCharm has it. So I need to
right. I'm not as used to PyCharm, but I think you can run that Jupyter Notebook right from within PyCharm as well.
So yeah, it used to be. I know it was here. So pure Python, Django, Flask, React Native. No, and this is PyCharm Professional. So this is where I thought it would be. Hold on. Now we're gonna do Google Foo is what we're gonna do.
All right. It's still starting. It's
Absolutely.
taking longer than usual to
Yeah, no,
start.
that's insane. That would if I was gonna use that, I would be upset, I think. So- and PyCharm, Jupyter Notebooks port. So Jupyter Notebooks integration. Right. Quick start. Create a new Python project. Specify a virtual environment. Install the Jupyter package. So maybe that's where I'm missing for me in this particular place. All right. So let's see here. Just for fun, we'll call it a new project. We will pick our Python interpreter, pure Python. Create a main welcome script. All right, well, we'll open it in this window. I'm a huge fan of PyCharm for work because we use a lot of Docker stuff, and you can integrate it in and just run the environment with the Docker containers, and also do a lot of debugging, which I like a lot. So in our project interpreter, we will go ahead and add was it Jupyter. I can never spell this thing. There were Jupyter. Jupyter. There we are. We'll just do the main package there. Install package. Because I think purely exploring the definitions that are written in the book or may help someone, you know.
Yeah, absolutely. Seeing us walk through it like this. So did the binder thing ever finish?
Let's go see. That's a good question. Jupyter Notebook. This is the viewer. Maybe is this it?
Yeah, maybe it is.
Looks like it finally maybe did a thing. Notebook. Chapter 1. Ah, looks like we are actually in a Jupyter Notebook
Oh, great.
here. So we can, so as we're, if anybody who's not familiar with the Jupyter Notebook or whatever else, so what you can do is you in order for everything to work in order, you actually have to work through it in order.
Right, top to bottom.
Yeah, and so that means you can't just go. I can't just go ahead and drop ourselves into our current chapter and make it run. Now, that's not necessarily true because what all I really need are the import statements.
Correct.
So I can go ahead and in you can see this first frame is highlighted. I can go ahead and run that frame and import our stuff. Now we also are going to want our data from our data directory. So I'll go ahead and run that as well. And then again, we're defining paths for things. So I can run that. So in a perfect world, that means I should have access to all of the data and all of the CSVs that we're looking at for our pieces of our stuff. And I should just be able to go ahead and move down here to our exploring categorical data. Now, I've been wrong many.
I would say give it a try.
Yeah, and so we'll go ahead and pull this data in. So DFW, which is Dallas Fort Worth, we're going to read this CSV Yep, absolutely. It ran and it brought us into our data. And like I said, Pandas supports bar charts. So we're looking at this stuff here. I guess what we'll go ahead and do is let's find, I'm going to get out of our PyCharm instance since this is working.
Yeah, that sounds good.
And I know I've got our instance here. So exploring binary, can I talk today? Binary? I don't even know what binary data is. Binary and categorical data. So it looks like we're still dealing with things like mode, expected value, bar charts, and pie charts, things of that nature. So let's just go ahead and we'll like kind of look at the at our notebook if that works for you, Nathan.
It does, yeah.
Okay, so we'll go ahead and look down here and we'll see. All right, so we've got um, AX, which I'm sure is an axis, right? So we've got
Correct.
our x-axis is DFW. We're transposing plot the bar chart. We're making the figure size 4 and 4. We do not have a legend for that, but we are giving it labels. So we have an X label, which is the cause of delay, and a Y label, which is the count. We are going to plot this in a tight layout, and then the plot is going to show. And so that's what we're seeing here. Fig size 4 and 4. I'm not sure what that represents.
Well, if we wanted a bigger picture, we could just change it to 6 by 6.
Oh, and that's what I was fixing to suggest is why don't we just go ahead and slop some numbers in here, right? So we just go ahead and say, all right, we want to see a different set. So we'll run that chart. Oh, bang, bigger chart. So it's 6 something, probably not 6 inches, but 6 something
Yeah.
that we're looking at. I would like to see, we'll just, for the hell of it, let's say legend is true. So we'll see what that looks like. And it gives us a legend.
Blue is everything, right?
Yeah, but there, we don't have anything else. So yeah, legend is there. So we'll just go ahead and swap that back to false. I like this. I like playing with this still here.
Yeah, absolutely.
So
this is pandas that we're using here, and pandas is behind the scenes using matplotlib. So all these different options and parameters that you can set here would be documented, probably not in pandas documentation so much as they would in matplotlib, but it's nice that pandas just with that one line of code, the data frame .plot .bar, you're getting a basic bar plot without having to just describe things in matplotlib syntax.
Absolutely. So I'm just messing with numbers, messing with things, and see what we can kind of make it look like. So we go to the 6 by 8. All right. So obviously the first number is width, second number is height. So we have a 6 by 8 there. We'll go ahead and swap that back to 6. And just for the hell of it, I'm going to play with this, and I'll be like, why are we late? And do that. So there we are. Why are we late? The carrier, air traffic control, weather, security, inbound traffic, whatever that is. So that's kind of fun right there. So yeah, that's gives you a really easy picture of how easy the data is to just go ahead and pull it in, plot it, slap your axis on there, and then take a look at what the layouts are. So let's just say maybe.
What if we took the transpose out of there?
Ooh, that's a good question. So we'll remove transpose. We'll run that. So I like that it like immediately gives us like new colors, new things.
So now if you turn the legend on.
Yeah, let's try that. We have a legend. And now we have it. So this is why we're late. This is what's going on here. So now, like you said, this now clearly describes why what each of the bars indicate and what they're doing. So
Right.
that's a very good way to do that.
So
Go ahead.
if we had like different months, month over month, why we were late, then you could have the months along the x-axis and then these series of
Oh, so it
the
would do,
reason.
yeah.
Right. That's probably why you would do it in this way as opposed to labeling the bars. You know, when we've only got one time period or one meta category, probably makes sense to do it with the transpose like they had it before, but this gives you another option.
Well, let's take a look real fast. So we've got our data here in the deal in the repository. So hold on, let's see here. Of course, Zoom is in the way right now. Thank you, Zoom, for everything. So with Python notebooks, I'm gonna go ahead and close this out, and then we'll get rid of our install. So the data here, we know that we went ahead and this is the DFW. So here we are. Airport delays, CSV is what we're looking at. Airport stats. No, thought that would be so maybe DFW airline CSV. Yeah, so it's only one.
Okay, there's not much data behind there.
Not enough to do like what you were talking about, or we could go ahead and group it
Sure.
via months.
You know, another way to see that is we turned it into a data frame called DFW. If you create a new cell right below this and just do DFW.head, that'd give us the first 5 rows of that data frame.
Okay, so let me, where is our paste a cell below? Wait, hold on. Need to insert a cell, right? So we're going to add a cell. You said below, correct?
Yep, there you go. That looks perfect right there.
Okay.
And then if you just type in DFW, it should show you the whole data frame. And yeah, if you run that.
So we have our carrier.
There we go. If it was a bigger data frame, you could do DFW.head. It would give you the first 5 rows. We only got 1 row, so yeah, not too much more we can do with this chart than we've already done, I don't think.
No, we said, but that's a really good example of the effort that we could do there. And so I said again, what did we do? What did they have before here? So it was I'm so used to code completion now. Right. So transpose.
That's right.
And then we did the dot plot, dot bar. We had our fixed size. I'm teaching people like a group of veterans to code, and they're using like VS Code, and they're using like very light code editors, and they like them, and I'm like, but you don't understand how much better it is to have something like PyCharm or WebStorm or something where it just like code completion, and you can like search the entire project for methods and things. That's anyway. This is it's one of those like the real programmers use Vim arguments, right? So okay, let's say if we did that and we approach it, we did that. What are we going to do here? So that actually gave us something wrong. So transpose.
We just missed it.
Can I not spell transpose? Is that what it was?
You're close. You just short an S, it looks like.
Transpose. All right. So yeah. So that gives us the exact same thing pretty much without X and Y labels. Apparently the tight layout doesn't even do anything, and the show doesn't do anything. That gives us all kind of that we really need. Maybe the show method is for the other labels.
No, I think Jupyter can just be set to automatically display the matplotlib without the show.
Okay.
It just depends on your environment setup, I think, or the version of Python.
Yeah. Makes absolute sense, but that was like the super fast, easy way.
Exactly, the one-liner, I like it.
To knock that out, and then as you said, we could just go ahead and take the transpose out and then give it a legend. and then we will end up with.
I didn't get that.
Whoa,
Could you
hold
try
on.
again?
Hold on, Sarah. You're not involved. You're not involved in this class. You're not here. You're not doing any of that garbage. And I haven't checked our participants here in a minute, but it's still just you and me. Nobody else is trying to get in.
Okay, that's cool.
So here we go. So, pandas all supports bar charts for displaying a single categorical variable for correlation. So so the S&P 500, I'm assuming that's our stock market stuff. We're going to run that.
Yeah, was this for this week or next time?
Is it? Yeah. Hold on one second.
I don't know how far we're going to go today.
Well, so binary categorical data, does this fall in that? This is correlation. So yeah, no, this actually does not fall into our weekly examples, but here we are. So I'm going to go ahead just for the sake of our to get back to that, we'll go ahead and make our legend false. And then there we're good. That's our chart. And then we had it four by four. We won't have to mess with that.
Looks good.
Yeah. It's pretty simple. So we'll go ahead and back here to the text and kind of like look at this and see what we're going to do here. So again, mode. Look you. So our mode again is the most common value, right? We look at that and see what happens. And let's say we have this is airport. This is all inbound stuff. So this is what we're working. Mode simple summary, whatever. Expected value is a special type of categorical data in which the category represents or can be mapped to discrete values on the same scale. So that when we were looking at our chart here in the bar chart, we understand that like what we're looking at is frequency of what's going on, like why these inbound flights are late or why things are delayed, what's going on there.
Right. So if we knew that the weather was the cause of delays about 30% of the time, and we know that we've got 1,000 examples, then we would our expected value for weather delays would be 300. So you have some expectation of what the probability is, and then you just take that times the total number of examples that you have, and that gives you the expected value. There's a fun book called How to Not Be Wrong by Jordan Ellenberg, which is have you read that?
Is it the How to Not Be Wrong Mathematical Thinking?
Yeah.
Yeah, I love that book.
Yeah. That's what when I think of expected value, there's a story in there about the guys who figured out the expected value for the lottery tickets, or the were actually higher than the price of the tickets. If they bought enough tickets, then they could expect to actually make money on the lottery and under the right conditions. So that was a story about expected value that stuck with me.
And that's a really cool story. It's also a story that like I remember based on like they had to do so much work to win the lottery because you couldn't use a machine to fill the tickets out. They had to fill them out by pen and paper. And so like it was like literally like when you broke down how much money they won versus how much work they did, like their hourly rate was so poor. It was terrible. That's a great book. The other example I love in it is about the law of what is it? Is it the law of large numbers, or where the guy he was imprisoned and he flipped a coin like every day for like 10 years, and it was that as the amount of times he flipped the coin increased, it came closer and closer to the actual like 50-50 percentage.
Mhm.
And I can't remember what that's called. It's like it's the law of large numbers, or there's something of whatever. But I love that example because you're as human beings, we like to assign patterns to things that don't actually have patterns.
Right.
Like I'm gonna flip this coin, and next time I'm gonna win. Like because it's been heads 5 times, it's gonna be tails the next time.
Right.
And
Right.
that has nothing to do with the actual probability of what will happen.
Yep.
Yeah, that's a great book. I love that one. How Not to Be Wrong. Yeah, I'm still wrong a lot, but
Me too. I read the book and still this happens.
I'm mostly wrong about people and not like probability. That's a different story entirely, right?
Yeah. If you can write that book, I'm sure that you will find your way to bestseller lists everywhere.
My favorite one of my favorite quotes about human behavior comes from the movie "Oh Brother, Where Art Thou?" And
Oh yeah, that's a good one.
it's a fool that looks for logic in the chambers of the human heart. That's the truth. So yeah, no, expected value, like you said, that's if you know that you have got a pretty good you've been tracking things for a while, and 30% of your your failures or your late things are based on weather, like you said, then like you can expand that out from if it's 100 times and it's 30, and then you get out to 1,000, it's 300, and then we keep going on from there. That makes a great example for that. So let's see here. Yeah, we're not going to go ahead and do the math for that. We're not going to jack with that. If you can't figure that out, probably maybe this is not the audience for you, or there's not enough crayons and glue for this guy to put it together. So now we are in probability, and we talk about the probability of a value occurring. We all have like an intuitive understanding of the way things should work because we've experienced it often enough. But human beings are terrible really at actually applying the rules of probability to our lives. Like you're like, oh well, like it's worked for me every single time. I don't know if it was in the same book. There's another one about surviving disasters, and that I've read, and it talks about the people who live in disaster prone areas, so people who survive earthquakes, people who survive hurricanes, the older they get, the worse their odds of surviving those events occur. But because they survived 4 or 5 of them, they think that they can. And so they tend to make terrible choices with regards to long-term survival in those situations.
Yeah, that's really interesting.
Yeah, because you're like, oh, when I was 30, I survived 4 hurricanes, but now that I'm 70, and then
Yeah.
the one hurricane happens and it ruins your whole life. And I'm walking around looking for my charger because my computer's fixed to die. So give me one second.
Well, I think a lot of people are making these probability calculations now with regard to COVID vaccine of, what's the probability that I'm going to have a bad reaction, or that it hasn't been tested enough, or whatever, that it's going to go bad for me, versus what's the probability that I would get COVID or spread COVID to somebody else. And again, it's hard for the average lay person to make those calculations, first of all, we're not that good at math, and then also, the probabilities, we don't have years of experience to draw on, and so it's tough to find the right ways to estimate those probabilities for ourselves.
Well, and sadly, terribly, over the last X number of years, our trust in information has been eroded.
Right. So you don't have the right basis to assess those probabilities.
Absolutely. So you can't just sit down and say, okay, this is the math and this is how this works. And like I said, like, you know, evenly though, you know, like I like this little piece here. It's like, surprisingly though, the concept of probability can be the source of deep philosophical discussion, which is what we're talking about right now, right?
Yeah.
Where you know, we can say that, you know, absolutely we know how this is supposed to work, we know how this is supposed to be, whatever else. I'm going to highlight that because yeah, look, I know where this stuff is at. Okay, you don't have to tell me. I'm fully involved. You know, but like it says here, fortunately, you don't need to know anything about it. All you need to know is that an event will happen in proportion, you know, that it can be repeated over countless times. And this is the stuff that we don't have, sadly, is that um you know, you can survive 3 hurricanes and think you're hurricane proof, and hurricane number 4 kills you. And then, you know, we sit down and gather 200 years worth of data about how many people survive hurricanes, and you're like, yeah, you really only had a, you know, a 60-40 shot the entire time. And so yeah, I like this. Most often, this is an imaginary construction. Yeah, that's a hard thing to deal with, because we don't, nobody wants to believe that they don't understand their own life and what's going to work for them.
Sure. Well, you know, some things you really can't test. I mean, like thinking about ESPN will show you the win probability during the game as it progresses, and it will sometimes swing really wildly back and forth between the two teams. But there's never been another game exactly like that, with those exact players at that exact point in their career under those exact conditions with those refs and everything else. So there's no way to be proven wrong that the probability at this point was 90% they were going to win, and then they actually ended up losing. Um, so there's always assumptions behind our probability.
Mhm.
And I guess if you watch enough of those um, games, you would be able to tell how much confidence to put in the probabilities that's being assigned.
Mm-hmm. Yeah, and that's exactly it, right? You know, you can say like, okay, well, you know, in the last X number of years of data that we have, you know, no team has come back from a deficit of this many points in this amount of time. And
Right.
then what happens is they go into the locker room and the coach says, you know, you guys have got to make it. You're going to win. You're going to crush it still. You know, and they come out and they beat the odds. You know,
Right. Right.
and that's why sports betting is like fun, or people get excited about it.
Exactly.
I know a gentleman who lives here, and he makes all of his money on horse races and
Oh wow.
horse betting,
Yeah.
and he has a massive data set, and it's basically like he can't, and he still can't tell you like this is going to win, this is going to be whatever. He was like, these are just the odds. You more than likely, you bet in this range, you will get a return. And
Mm-hmm.
it's like over X, you know, 15 years, whatever. I've got this much data, and I can tell you that you will make money. He was like, but if you want me to tell you, like on race X on X day, this horse is going to be the winner, he's like, I can't tell you. Like, we don't. That's not what I do. So
Sure.
yeah, same thing. So again, the key ideas that we're looking at here, categorical data is typically summed up in proportions and can be really easily visualized in a bar chart. We might represent distinct things: apples, oranges, males, females, levels of factor variable or numerical data. Expected value is the sum of values times their probability of occurrence, like you said. So, you know, you're like, all right, I've recorded this 10 times, it happened 3 times, that's 30%, and that's what we expect that value to be, even if we expand it out to more occurrences. You know, to 100 times it's 30, when to 1,000 it's 300. That's what we're looking at. If it doesn't match that, then we can start looking at why our expected values don't match up with what we've got. But it's a thing there. So we said there are no statistics course is complete without a lesson on misleading graphs was often involves bar charts and pie charts. Hold on, I've got to click on this link. I want to see what page we find ourselves in for misleading graphs. Okay, well, it's a Wikipedia page. That sucks. All right, hold on.
Yeah, there are some good pictures towards the bottom though.
Yeah, I was going to say, let's see that. So, misleading pie chart. That makes this look more significant than it is, because it sticks out, right? We're like, oh, obviously C is important. Well, no, it's just 5%. So
Yeah, your data science people are generally not going to be a fan of a pie chart regardless. But if you make it a 3D pie chart, your data science people are they're not going to have a lot of confidence in your presentation. So,
right. There you go. So like when they're like, when you go in for your data science job interview, they're like, what kind of chart do you like? You're like, oh, I love pie charts. And they're going to be like,
yeah.
they're going to be like, it was really nice to meet you.
Yeah.
Make sure to pick up your swag bag on the way out and go ahead.
Exactly.
I know now after our last lesson, we know you're like, oh, well, I really like, the box plot thing.
Exactly. Now you're talking.
And then now they're like, ooh, you know what a box
All right.
Now we're gonna now you're on the way. So okay.
Exactly.
So yeah, this is interesting. Like I said, I have to check this out. But so this was like I said, I like this. We finally got to hold on. The colonel died. That's just that's not the fried chicken guy. That's the colonel or whatever. We'll try to restart it and see. But this was good. That we could come in here and do this.
Yeah, that was a great experience.
Obviously, Binder. Either A, this is a massive notebook and Binder had a hard time dealing with it, or B, Binder is a terrible place to host your Jupyter notebook.
I think it just probably has a short timeout for inactivity.
If you work for Binder, I'm not talking shit about you. That's not what's happening right now. Never use your service. This is a one-time thing. And this is a massive series of notebooks, and so it could very well be difficult to work with. But that was nice to be able to play with the size of our charts, the way that we transpose things, the stuff that we do, and finally actually get to do some code examples in there. I liked this. I liked the binary and categorical data. I don't feel like we touched on binary at all.
I think it's just a subset of the categorical data, but you're right. They didn't really get into it.
Yeah, because we didn't do true or false. We didn't do like yes or no. We didn't do like raining, not raining. We didn't get any of that kind of stuff. So that seems kind of like a weird thing to do that. But categorical data, that makes sense.
Yeah. And a lot of times the things we're trying to predict are binary. Like you say, is it going to rain or is it not going to rain? And so it's important to know how unbalanced your data set is. Often we're trying to predict things that are kind of rare. And so you'll get something that happens 10% of the time. 10% of your examples are yes and 90% are no. So you need to know that before you start. So doing a bar chart is a good way to tell, or if there's only two categories, you can just look at the numbers, just look at 90% or whatever percent. It's easy to see even without a visual, but it's important to know the distribution there.
That's fun. Oh, okay. Well, yeah, our kernel died, so I don't have that.
Yeah, might have to re-import your libraries.
So that and that's kind of like basically what the binary portion of this data that we're looking at would be how likely are you to have a delayed flight or not a delayed flight, right? Delayed.
Yeah, exactly. That'd be a good binary question to look at with that data.
All right. So that seems to be kind of like a fall down point here. Like all right, we have categorical data, but what are you trying to answer? What's the question? Are we going to be delayed? Or are we not going to be delayed? And like I said, they did not really put that in here. Well, hold on. Let me look. I said that. Let me read this real fast. Getting a summary of the binary variable with a few categories is fairly easily. I guess maybe that's what they were saying. Like you are going to be delayed or not be delayed via categorical data. All right. I'm sorry. I didn't mean to talk bad about y'all. Practical statistics for data scientists. Maybe we're just. I'm looking at the, like I said again, at the crayons and glue version where I want to know why that's a binary question, and how we found it through categorical data. But all right, if looks like we're at the end there. If you are following along in the videos and you want to know what we're going to go over next week, I think it looks like correlation is next. We have scatter plots. Probably that's not enough information just to do in one session or 1 week. It just depends on what that looks like. We've already got kind of a picture here of correlation. And then it looks like we get, well, I don't know, there's quite a bit looking forward, but I feel like maybe we should be ambitious. Maybe we should do correlation and then move on to the exploring two or more variables.
Yeah, I think that'd be fine.
See if we can't get both of those things done.
Yeah, that'd wrap up chapter 1. Then we can move on into chapter 2.
Awesome. And then maybe the summary can be its own piece, but
yeah, that's true.
Those look like things that we can do. So I will add on our GitHub page that we will tackle correlation and exploring two more variables next. And we'll move on from there. Does that work for you, sir?
That's good. Have a good week.
All right, let's hold on. Where's our there we are. So we have to stop our recording. So all right, we already said that we were going to have a good week. I'll just edit that piece out. We'll work with